A bolt circle occurs when bolt holes are periodically spaced in a circular pattern. Bolts arranged in this pattern offer the most stability and strength for machined parts and are often used in flanges and wheels. Bolt circle patterns typically have 3 to 8 bolts equally spaced along the circumference of a circle, forming a triangle, square, pentagon, or other equilateral polygon. The lines that connect two of the holes and the center of the bolt hole circle form a triangle. The center angle of each triangle can be found by dividing the total number of degrees in a circle, 360, by the number of bolt holes. For instance, a 3-bolt circle has a center angle of 360 divided by 3, which is 120 degrees. A 4-bolt circle has a center angle of 360 divided by 4, which is 90 degrees. One of the most common bolt circle patterns is the 5-bolt pattern found most often on wheels. In manufacturing, it's useful to determine the location of the holes relative to the coordinate axes. To do so, let's first determine the value of the angle between each hole. 360 divided by 5 equals 72. So each triangle made by 2 adjoining bolt holes is 72 degrees. Next, we know that the first bolt hole is exactly aligned with the y-axis. Additionally, the value of the angle between the x and y-axis is 90 degrees. The second bolt hole is 72 degrees from the first hole. 90 minus 72 is 18, so the angle between the second hole and the x-axis is 18 degrees. The third bolt hole is 72 degrees from the second. However, we've already determined that the angle between the x-axis and the second hole is 18. Therefore, the angle between the x-axis and the third hole is 18 minus 72, which is negative 54. So the third hole is at an angle of negative 54 from the x-axis. The value is negative because it goes below the x-axis. Since the holes are equally spaced, we know that the second and fifth holes are at the same angle above the x-axis. So the fifth hole is also 18 degrees above the x-axis. Similarly, the fourth hole mirrors the third hole and is negative 54 degrees from the x-axis. If the radius of the bolt circle and the interior angle between two adjacent bolts is known, then the distance between each bolt can be calculated using the law of sines. If we look closely at the two adjacent bolts, we can see that they form a triangle with the center. We already know the center angle. It's 360 divided by the total number of bolts, 5, which equals 72. We also know the value for two of the triangle sides. Since each bolt hole is on the bolt circle, those sides are equal to the radius of that circle. Next, since the two sides are equal, we know that the angles opposite the two sides are also equal. And finally, since there are 180 degrees in a triangle, one of the angles is 72, and the other two are equal, we can solve for the other two angles. Now that we've collected all the facts about the triangle, we can use the information to solve for the third side, which is the distance between the two bolt holes. Using the law of sines, we can rearrange the equation to solve for the unknown side. Substituting in the values we know, we can then calculate the value of the third side. The value of the third side is equal to the distance between the two bolt holes.